Have you ever stopped to think about how your laptop just finds your printer on the Wi-Fi? Or how your phone knows exactly where to go to stream a video? It can feel like magic, but it's not. It's actually a fascinating little detective story that happens every single day right inside your network.
So, here's the real puzzle we're going to solve. To talk to another device on your local network, your computer needs its IP address, sure. But that's just a logical address, like a name in a directory. It's not enough to actually deliver the goods. It needs something way more fundamental, a physical address.
All right, to make this super clear, let's set the scene. We've got two main characters in our story. First, there's PC1, who wants to send a message. And then there's PC2, the computer it's trying to talk to. They're both hooked up to the same local network, and PC1 is ready to send.
And here we have the heart of our mystery. See, PC1 knows PC2's IP address. You can think of that as its street address. But to actually get a package to the front door, it needs the physical hardware address, the MAC address. That's kind of like the specific apartment number. And right now, that's just a big old question mark. And this is absolutely key. Without that MAC address, PC1 can't even start building the digital package, the thing we call an Ethernet frame, to send the message. It is completely, totally stuck. The message is all dressed up with nowhere to go. So what's a computer to do? Well, it puts on its detective hat and starts an investigation. And its number one tool for the job is something called the Address Resolution Protocol, or ARP for short. This is how it starts tracking down that missing MAC address. The whole ARP process is actually this beautiful, simple three-act play. First, there's a public request for information. Then, the network makes absolutely sure everyone hears that request. And finally, the right device steps up and gives a direct answer. Now, PC1 doesn't just whisper this question into the void. Nope. It basically stands on a chair and shouts it to the entire network. The message it sends is pretty much this. Hey, everyone. I'm looking for the owner of IP address 192.168.1.20. If that's you, can you please tell me, 192.168.1.10, what your physical hardware address is? This shouting has a technical name, of course. It's called a broadcast, and it uses a very special destination MAC address, all Fs. That address is the universal signal for, hey, network gear, send this to every single device connected to this local network. Nobody gets left out. When the network switch, the central traffic cop, sees a message addressed to all Fs, it knows exactly what its job is. It doesn't even try to look for one specific destination. It just acts like a giant amplifier, taking that one message and blasting a copy of it out of every single one of its ports. It makes sure every connected device gets the memo. This really highlights the two completely different ways devices can talk on a network. The ARP request we just saw is a broadcast. It's a one-to-all shout in a crowded room, perfect for discovery. But the answer, which we're about to see, is what's called a Unicast, a quiet, targeted one-to-one private conversation.
Okay, so the shout has gone out. The entire network has heard the request. Every device, your printer, your phone, your smart TV, they all take a quick look at the message. And now, our detective gets its first real lead. So while all the other devices see the request isn't for them and just drop it, PC2 sees its own IP address and says, hey, that's me. It then puts together an ARP reply, but, and this is important, it doesn't shout back. It sends a private Unicast message straight back to PC1 saying, yep, I'm 92.168.1.20, and here's my MAC address.
Now that PC1 has this vital clue, it doesn't just use it once and throw it away. Oh no, it's much smarter than that. It opens up its internal case file, its memory, to log this new discovery so it can remember it for later.
Before getting that reply, PC1's internal address book, its ARP table, was empty, at least for PC2. It knew the IP address it was looking for, but it had no idea what physical MAC address went with it. It was a total blank slate. But the second that ARP reply arrives, bam, PC1 immediately updates its ARP table. It creates a brand new entry mapping the IP address 192.168.1.20 directly to the MAC address it just learned from PC2. Case closed. The clue is officially recorded. And you can probably guess why this is so smart, right? It's all about efficiency. By keeping this little table, the next time PC1 wants to send something to PC2, it doesn't have to go through that whole shouting process again. It just takes a quick peek at its internal notes, grabs the MAC address, and sends the message directly. Way faster.
Now, this is cool for finding devices in the same room, but what's really wild is that this exact same detective work is the fundamental key to how your computer finds its way to the entire internet.
See, to get to the outside world, any device on your network needs to know where the exit door is. And in networking, we call that the default gateway. For pretty much all of us at home, that's our router. It is the one and only exit point for any traffic that needs to leave our local network.
So think about it. When you want to go to a website, your computer doesn't need to find Google's physical address out there on the internet. It just needs to find the physical address of its local exit door, the router. So it broadcasts a request, just like before, asking, hey, who's my default gateway and what's your MAC address? Once it gets that answer, it knows to send all of its internet traffic to the router.
So let's just step back and see how critical this really is. It all builds on itself. If you don't have ARP, you can't discover MAC addresses. If you don't have MAC addresses, you can't build the basic data frames. Now, data frames means no local communication, and if you can't talk to devices on your local network, well, you definitely can't talk to your router, which means no internet. It's the little protocol that makes everything else possible.
The whole system we just walked through, it works. And it works because it's built on a foundation of trust. It assumes that when a device is asked for its identity, it tells the truth. But that leads to a pretty interesting and maybe a little scary question. What happens if a device on the network lies? What could a malicious device do if it intercepted that request and claimed to be someone it's not? Now that is something to think about.